name is IKRAM bin AZMAN. I'm from BMMD 1/1. Today I will explain to you about the objective of this assignment. Objective number 1 is to draw detailed FBD from actual structure related problems. Objective number 2 is to develop equilibrium equation from the FBD structure. And last but not least, to analyze force member from the structure. For this assignment, we have chosen the door handle as our actual structure. So, I will explain about the mechanism of the door handle. A door handle controlled by the manipulation of the latch, a mechanical fastener that joins two or more objects together. In this case, the latch connects the door with its frame and tends to embody a sliding bolt installed in the door and receptacle in the frame. The latch position is determined by the handle, which can take many forms including knob and lever. This is connected to the latch via a spindle or cylinder. When the handle is pulled or rotated, the action is carried by the spindle into the cylinder, which turns clockwise or anti-clockwise depending on its orientation. The movement of the cylinder causes the attached bolt to be forced across the door internal face, sliding in or out of the frame's latch receptacle, allowing the door to be either open or shut.
Assalamualaikum, my name is Nurain bin AZLAN, and in this presentation I will be explaining about the original structure and the idealized model of our project. So, in the first slide, what you will see is the original structure. Okay, in this next slide, what you will see is our idealized model, that is torsion force on door handle. What I could explain is because the handle is long, the radius, which is the length from the axis of rotation, is greater. So that means that the torque equals the force times the radius. Therefore, if the radius is greater, the amount of force required to turn the handle is less. The same concept applies to both the door itself and the position of the door handle. The axis of the rotation of the door is the hinge. Thus, the radius is the distance between the hinge and the point to which the force is applied, which is the door handle. Once again, torque equals force times radius. Therefore, the greater the radius, the less force needs to be applied.
For the calculation part, we start with equation of equilibrium. So for x-axis, sum of fx equal to 0, and for y-axis, sum of fy equal to 0. And we assume that the force acting upward is positive, so we get Fi minus Fe equal to 0. As we know from the FBD, Fe equal to 82 Newton, so we insert the Fe into the equation and we will get F1 equal to 82 Newton. Next, for the moment, sum of moment is equal to 0, and we assume that the rotation anti-clockwise is positive, and we get negative Te plus T equal to 0, and T is the torque that apply on the door handle with the length is 0.18 meter, so we get Te equal to 14.76 Newton meter. Okay, next, for the internal torque, Ti, we calculate with Ti is equal to Te plus the T for the L2. So we get Ti equal to 20.5 Newton. Next, we will calculate the torsional shear stress. Shear stress is equal to T multiplied with C divided by J, whereas J is polar moment of inertia and C is radius in meter. So we need to calculate the J before we get the shear stress. So the equation of J is equal to pi over 2 multiplied with C power of 4. For our project, the radius is 0.02 meter, so we get J equal to 2.513 times 10 power of negative 7 meter power of 4. Next, after we get the J value, we will calculate the shear stress for allowable shear stress and the maximum shear stress. For allowable shear stress, we will use TE, which is the torque we apply on the project, and the maximum shear stress we will use TI, which is the internal torque. So for allowable shear stress, we get 1.175 megapascal, and for the maximum shear stress, we get 1.632 megapascal. Next, we will calculate the angle of twist, which is the equation is TE multiplied with L1 over JJ, and we get 1.355 times 10 power of -4 radian, and we need to change the unit from radian to degree, so we get 0.0078 degree. Next, for the maximum torque, the equation is shear stress maximum multiplied with J divided by radian, which is C, and we got 20.506 Newton meter. For the maximum force, the equation is T max over C, and we got 1025.3 Newton. Last but not least, we will calculate the factor of safety, FOS, which is the equation is shear stress fail or shear stress maximum divided by shear stress allowable. So we get 1.389, which is in the range of 1.5 and 1.3.
Hi, Assalamualaikum. My name is Nurain. Today I will be present about the discussions of this project. In this project, we assume that the force that acted to the door handle is 82 Newton. To find maximum force, we have to calculate the torque at the shaft and the maximum shear stress. From that, the maximum force can be calculated, which is 1025.3 Newton. To avoid any incident, the force that acted on the door handle should be less than the maximum force. The value for the factor for safety is 1.389. If the value is less than 1 and more than 2, the structure would be failed. It is extremely important to calculate the factor of safety before test the structure. This is because if the structure fails, there will be a risk of injury and death to pupil, and also will give a risk to the company's financial loss. There is possibility to have a big failure. From this project, it can be stated that torque is a force applied at a distance that causes a change in angular momentum. A moment is also a force applied at a distance, but it does not cause a change in angular momentum. The magnitude of the torque depends on the applied force, the radius, and the angle between the force and the lever arm. The larger the force applied, the torque will be increases. An applied force can result in zero torque if there is no lever arm or the applied force is parallel to the lever arm.
Assalamualaikum warahmatullahi wabarakatuh. My name is FITRI bin YUSOFF. My matrix number is B0919101009, and I'm from Faculty Technology Mechanical Manufacturing. Okay, in the end, for the conclusion, from the mini project that we conduct, we can conclude that the calculation and this project are done based on the learning outcome, where we are able to apply our knowledge on how to calculate torsional force circular shaft. Next, we are able to determine the torsional deformation of a perfectly elastic circular shaft and determine the support reaction when this reaction cannot be determined solely from the equation of equilibrium, such as torque, shear stress, and angle of twist. Last but not least, you are able to determine the relationship between applied load and force action on shaft. That's all from me. Thank you for watching. Assalamualaikum.